All right, this is officially the last lesson for this first unit that felt like it's been going on forever. So after this, you'll get a review sheet and then we'll test on this stuff. So graphing linear inequalities. So remember, when I'm talking about inequalities, those inequalities are swoopity, be more, yeah, less than makes the L, greater than, and then you have your or equal to's. So the first thing we're talking about here, which we've definitely spoken about before, how many solutions do inequalities have? When you're looking at something like, x, x is greater than 8. How many solutions does that have? How many, answers? How many numbers are bigger than 8? So you might be remembering that inequalities have infinite solutions. Which means if they have an infinite number of solutions, then we can't possibly write them all down. Which is why when we're graphing these and we look at the solution sets, that's why we graph them on a number line and do that shading piece. That's totally going to come into play here. You might be remembering this. So when you're graphing these linear inequalities, it's just like graphing lines. You're still looking for the slope and the y-intercept. You're still doing rise over run. And you also still need to make sure. Okay, let's try this again. There we go. You need to make sure you solve for y. Just like we need that in order to be able to see the slope and the y-intercept, we still need to have y isolated when we're dealing with a linear inequality. The only difference is instead of being y equals mx plus b, it's going to be more of like y is less than or equal to mx plus b, or y is greater than mx plus b. Now, there are two new things because, like we said, inequalities are not the same as equations, so it does make them a little bit different. And the two new things that you need to remember to do when you're graphing linear inequalities are you need to remember to consider if it is a dashed or a solid line. Do you end up with a dashed line or a solid line? And then the second new thing you need to consider is the shading. Shading? Is there two Ds? I have no idea, guys. Let's just avoid the word altogether. So, shade. Cool. Remember, which way do you need to shade? Do you need to shade above the line or below the line? Okay, so I'm writing too big. Don't have enough room. So how to know which way to shade? And so we look at which way to shade by reading the inequality. And we'll talk more about that in an example. But so if you have something that says, y is greater than or equal to 2/3 x plus 7, after you graph that line as normal, you would be looking to see, okay, the inequality says that y is greater than the 2/3 x plus 7. So greater than, I would be shading above. the line. Okay, so the last thing we need to talk about is which inequality gets which kind of a line. So the dashed line is going to be for the less than and the greater than, whereas the solid line is going to be for the less than or equal to and the greater than or equal to. And that's because when you're dealing with the dashed line, points that are exactly on the line are not solutions. And that's because of that dotted line. That's because if I look at x being greater than 7, 7 isn't greater than 7, so that wouldn't work. Whereas with these guys, with the or equal to's, points that are on the line are solutions. And that's the same kind of reason. If 7 is less than or equal to 7, that's true, but 7 is not plain old less than 7. Not true. Not that x is confusing. We'll put false instead of an x in true. All right, so I think that's just about everything there.
Good morning. Just a reminder,
oh my
that
goodness.
the 712 picture retakes
Picture
are this
retakes.
morning.
Sorry to.
From
Yeah,
staff.
she needed that in
It's
her life,
7:40
right?
to 8.
So yeah, we're gonna look at some examples in the next one.
8:30 sophomore and freshman, 8:30 to 9.